Thank you, everyone. Thanks for joining. Happy Sunday. Hope you're all keeping well. This is class 6. Believe it or not, I think, yeah, we are on our third weekend. So slowly but surely we're marching on. Hopefully with the classes we've covered so far, hopefully they are still all sort of making sense. I want to employ us to reach out if and when we think we are stuck. I have I have the capacity to support you more than what we do in class. So if there's any need to reach out, please use Slack. If Slack does not suffice, do call me. So you have direct access to me. So I'm not just some random guy on YouTube teaching you. So you know me, you can call me if you need some top up or some discussion. Sometimes it's not even like you have a question. It's just you just want to bounce some ideas off me or you just want to have a feel of things. People do call me a lot and some don't call, some text, some chat. I've chatted with a few people already today. Please keep that coming. If I don't reply you straight away, I will eventually reply to you. So don't feel too shy or too embarrassed. I know question is silly, so I'm sort of reachable, approachable. Please, let's remember that. And also, I want to thank you guys. The people that are doing the work, I can see some people are really pushing the boundaries. I'm going to mention names. The people that have been doing especially the group A guys, I do appreciate you. But I'm looking at people that are attempting the group B task also. I am not saying that the newbie should go and tackle group B, but I'm seeing some newbie actually, define the other and going for it. Sometimes you do a project, you might not be able to finish the project, but in the course of actually having a go at such project, you will learn something. You might not even be able to finish because of maybe your lack of skill set, maybe you're not at that level, yeah, where you can tackle such task. But whatever you do, even if you don't finish, you would have picked up some things that would serve in good stead down the line. So the newbies, especially the newbies who are, putting their head on the parapet, having a go at group B task, kudos to you. The Adebayos of this world, especially, I think is about the only person who I would consider as a newbie who is attempting group B task. So I thought I just mentioned his name. I don't know if he's on the call, but even if he's not, yeah, he is on here. So well done to you. Fantastic. I think it's about the only green person, a newbie who is attempting group B task. So well done. All right. So today, I have an interesting topic I want to discuss. So we did look at version control yesterday. Today we are going to kind of move right back to infrastructure, especially on the cloud. So I have a question in mind that would allow us to, that's going to steer us in the direction I want us to go. In digging a little bit more into infrastructure on the cloud. My objective today is to introduce us to how you would do a little bit of infrastructure design, specifically on the cloud, and how to interpret those design into actual reality. It's just like an architect, somebody who has an idea of what his ideal home should look like. Oh, I want to have my, dream home. I want it to be a duplex, a 6-bedroom duplex with four bathrooms, a swimming pool, maybe a sauna, maybe a jacuzzi, maybe a lush garden, maybe 3 living rooms, a study, and what have you. Someone will have this in mind. And then you will sit down with an architect who will then try to actually get your imagination on a sheet. So they will capture what you want and they will, then find a way to actually pictorially represent your idea so that it will not just be something that is sort of, running in your head. It's something that can be pictorially represented. So anyone will be able to look at it and understand that, okay, this is what needs to be done. And that sort of design can then be passed over to the implementer, who would then look at the design and then try to bring it to life. Everything starts in the head. And at some point, it needs to go on a paper as design before it then moves to the people who actually do the work. The same thing goes with enterprise design, cloud design. So you all start from a problem that needs to be dealt with. There will be some discussions as to what will be the best approach to solving that problem. And at some point, there has to be a design document of what the approach should look like, so that that design document can then be passed to the implementers, who would then actually make that design come to life. I'm going to kind of play it in a scenario situation, and so that we will be able to understand a little bit better. And also, I will bring in some of the things we've learned and how they kind of glue into this space. For example, how does version control come into play? So I will introduce the problem first. I will play it in some of scenario based, how a DevOps guy will come in, how a solution architect comes in, how a developer comes in, how a project manager comes in, and then we will kind of glue it together and then we look at the problem. So the problem I have in mind, I wanted to make it as simple as possible. So let me share that here. Okay, let's have that. Yeah, but let's do it a little bit. Okay, let's see this one. I'm gonna move it next to this chart. Yeah. Okay. So the project is a two-tier application. So what is tier? So we want to build a two-tier application. What does that even mean? I'm going to kind of go through the question and then I will expand this. And I want us to, pay attention to some the keywords, tier, application, infrastructure as we kind of go along, front end, back end, etc. So project, a two-tier application. So we're creating a two-tier infrastructure, a front-end system, so running Nginx, and a backend system running Python 3 and Java 11. Each tier should run two nodes in different AZ availability zone for redundancy. Ensure you have a template to expedite VM creation. I'm going to go by this problem again, maybe in about 15, 20 minutes, but let's kind of do some background to understand some of the terms that are being used here, such as tier, such as infrastructure, such as front-end, such as backend, such as Nginx, such as Python and Java, and nodes, AZ, redundancy, template, and VM creation. A lot of buzzwords there that we need to basically untangle to help us appreciate the problem or understand it better so we're able to do justice to it. So typically, this is how a project will come to a team to tackle. So you might be a DevOps guy, you might be involved in some planning as to, let's say, for example, Ahmed is rolling out his Ahmed Enterprise, which kind of deals with import and export of cocoa from Osun State to London. So the cocoa will come from Nigeria and, go through maybe Lagos port and then all the way to London. He might want to kind of set up a portal. A portal is more like a website, but a portal is a little bit different from a website in the sense that a portal allows you to personalize what you see on a website. So I'm looking at building a portal so that a person, maybe a merchant, maybe a potential customer can get on the portal, log in, track their order, etc. And that's the main difference between a portal and a generic website. Generic website is usually static, where you go and just click and you see stuff. Whereas a portal personalize what you see. So, for example, when you log on the Yahoo email platform, that's a portal because it's personalized for you. That's different to going to www.yahoo.com or going to www.google.com, which is sort of generic. So a portal is almost like a website, but that is sort of personalized. So what you see will depend on your profile, your login, etc. So Mr. I may be looking at setting up a portal that kind of manages the way it deals with his client. So let's kind of represent that pictorially so that we will use that to explain this problem better, and then we look at the solution. So what we are saying is, I'm just gonna take this out. We dealt with this yesterday. So we have a merchant, and then let's just use. I hope Ahmed doesn't mind me using his name. So let's call him merchant Ahmed. So Merchant Ahmed he has a big farm, a cocoa farm in Ocean State, and he has sort of he has potential customers over the across the world who basically use this platform. Okay, on this platform, you can make cocoa order. Just look at that. On this platform, you can make cocoa order. On this platform, you can make you can track order. So when you buy something, you can track it, and then you can maybe, let's add one more thing. Let's put it like this. Let's say scan inventory. So do we have cocoa available to buy inventory? And then maybe also scan cocoa order, track order, scan inventory, probably registration, just registration. And then we'll kind of make this a different color. So these are the things you can do on a cocoa merchant platform. So let's call it merchant Ahmed cocoa dot com or .ng, something like that, cocoa.ng. Let's call it that. So this is his portal. And then you can log in. Maybe you log in as /Mumi, maybe /Akin, maybe /Wale, maybe /Tunde. So obviously what you see, it will depend on the what you order. The inventory might be the same, or registration might be different because if you're already registered, this might not be enabled for you. Your order will be your order. What Tunde is tracking will be different to what Mumi is tracking, etc. So everything kind of, and Ahmed sits here. So Ahmed sits here, he has his own admin portal. So this is like normal client portal. With what Ahmed sees is different. Ahmed sees how much money is coming. All he sees is money. Money. That's what he sees. And he says, how many customers do I have? How many delayed order do I have? I want to look at his inventory as well to see if things are being delivered quickly, etc. So this is the admin side. He sees money, of course. He looks at his inventory as well. inventory, and so forth. So this is what the merchant sees. So this is the merchant sort of, if you like, the admin side. Admin, okay? And this is what the run-of-the-mill customers or client would see. So if Ahmed is coming in, this is what Ahmed sees. Because he logs in as an admin. Well, he goes there. The portal will take him there. And the rest of the world, people like us, we go here. So let's put this one here. That's what he types in. And that's what takes him there. So the other people will type their own link on the browser. And these are just the run-of-the-mill guys. Okay, people like us. So we will log in, and then the portal takes us to the normal user kind of, because it's a portal, it's still personalized. We won't see the same thing. Yeah, it's going to be a variant of what a customer should see depending on what the customer profile looks like and what is ordered and all the rest of it. So that's what the journey will look like. Let's take this out. Right, so this is how things will look, okay? So Ahmed comes and this is what I want to do. I want to have my own portal, and he comes and they say, okay, all right. So, and he will also say, okay, as a merchant, Ahmed, I want to be able to control, what the inventory looks like. I want to be able to track my money. And as my customers, I want them to be able to make orders, do registration, make payment, and all the rest of it. And then you look at it and say, okay, all right. So imagine this was somebody trying to explain what go through what is ID home should look like. So you will be talking to.
Just checking on you. Yes. Do you care for a cup of coffee?
Apologies for that. So this would then have to be interpreted into infrastructure layout, as well as how the actual coding, the writing of the code would work. So obviously somebody needs to write this as code, but the code has to live somewhere. So there will be the code design and the infrastructure design. Infrastructure is the machine. What kind of machines are we going to need? The code design is how will the other system work? How will it track? How will payments work? What kind of API are we going to use? So there will be at least two sort of discussions going on. The coding part as well as the infrastructure part. Because at the end of the day, the code will have to live somewhere, will run somewhere. So on the coding parts, they might not say, okay, all right, Mr. Aben, we get what you're saying. So I think from like a technical standpoint, you would need a database. You might not understand this, but the people that are involved would say, okay, we need a database where customer information will be kept, orders will be kept, inventories will be kept, inventory will be kept, etc. So this would be a database. Okay, they might also say, okay, we need to write a code. So this code, and then they might say, okay, we're going to use the Python code to fetch, to persist, to write stuff in the database, as well as fetch stuff from the database. Okay, so the Python code would do like one, write stuff to database, and then feed off the database as well. And then they might say, we need to make the platform pretty. So they might say, here, we're going to have some beautiful web HTML thing that the customer sees that would be the presentation layer where the customer will, what the customer will actually engage. So a customer will type like this guy, they will type something on the browser. That would be the web HTML stuff, like welcome, put in your username and password. And when they do that, whatever needs to be done will be done by the actual logic of how the login would work or how inventory will work will actually be managed by the code. But the beautiful layer will be done by HTML. So the customer, when they want to use the platform, they will go to www.something.com. When they get there, when they try to authenticate, the Python code manages that. It will check if the customer exists in the database. If it does and the authentication is correct, it will fetch it and then will print it on the web platform, and then the customer will see a beautiful web page. If it's not correct, you would see like an invalid login on here, but this is the guy that's sort of doing the heavy lifting, going to database to verify and then sending the result back to the HTML. The HTML is more like if you like the secretary who is fronting for the boss. So this is the boss. The boss would go and check in the engine room to see if things are working. If things are working, it will report to the secretary. The secretary is the one that will always interact with the user. So that's how it kind of works. So this is me trying to kind of oversimplify it, but roughly this is how things work. So we'll then call this a tier system. It's almost like a level. So this we can call this level 1, which is where the customer gets to first. And this is level 2 and level 3. Level 1 is almost like the web page static artifact side of things. Level 2 is where usually the code that you write lives, and level 3 is more like the database, if you like, if you want to use the right word, the repository where things sit. So instead of using level, people actually will use the term called tier. So this is tier 1, which is your presentation layer. Presentation, presentation, or front end, if you like. And then you will move to, and that's this tier. And then you will then have tier 2. And then tier 2, which you can call application layer or logic. Or some even call it backend. And then if you can, if you want to call this, and then you have tier 3. Which is the repository or the database. Repo database, okay. And this is how you typically have it. So tier 1, tier 2, tier 3. Okay, the tier 1 is like the gate man that is going back and forth, no brains, but you can do the heavy lifting, you can go back and forth. This is the brain. This is the guy that you don't see that's sort of moving the strings as the tier 2. And whatever data it needs is getting it from the back end, which is the database or the repo. So this is a 3-tier system. Sometimes you might have it as 2-tier. Maybe some systems don't need logic, and you just collapse tier 1 and tier 2, and you make it 2-tier instead of 3-tier. But generally, most app will be a 3-tier system. And because we are in the early stages of our learning, so I've deliberately excluded this so that we can just focus on tier 1 and tier 2. So for Mr. Ahmed to actually get his work done, you probably need a 3-tier system. So presentation, where the web things will live, the backend, and maybe a database system. So if we wanted to represent that pictorially, so we would do something like this. Okay, let me go back. So for the web HTML, in terms of what we're going to need to make that work, we're going to need a machine. Let's put that there, a machine. And that machine has to be running a web server solution for it to function as a web tier. So we're going to need a machine that functions as a web server solution. And the options we have there would be something like Nginx, something like Apache Web Server, something like Microsoft IIS, Internet Information Server. I don't know if they still use it. But the clear winner here are Nginx and Apache Web Server. So those are the popular web server solution that this machine needs to run to be able to function as a web host. So that does not include the artifact that has to be specific to AppMed portal. So things like AppMed logo, AppMed address, and what the rest of it that needs to drop here as part of the web solution. Then for the Python code, which is where the logic is managed, that machine needs to run Python. We're just assuming here that the code implementation will be in Python. It could have been something else, it could have been JavaScript. It could have been JavaScript. It could have been Java itself. It could have been Go. It could have been Rust. It could have been, there's so many languages out there that you could use for your backend. It all depends on what the development team decides to use. But you as a DevOps person, you need to facilitate that by providing the right binary, which is installations, to ensure the app will run as expected. Okay, so you need to make sure you have the right binaries to ensure the app will run as expected. So in this case, let's say we were simplifying this to just be a Java backend system, sorry, a Python backend system. You then need Python, or let's say it's a Python and Java backend system that needs to be. Then you need to have Python and Java on the system. Okay. And then you talk about the actual repository, and that will be a database system. There are sort of different kind of databases. You have key value database, you have relational database management system, you have time series database that they're just like cars. You have different kind of car horses for courses. Sometimes, you can call this almost like a vehicle. So sometimes you might need a truck. Sometimes you might need an SUV. Sometimes you might need a saloon car, depending on the task at hand. That will kind of decide or determine the sort of database you need to use. There are different kind of database systems out there. So we're just going to represent it as a DB engine because that could be anything. So a DB engine. And then you're almost good to go. So you have a three-tier system whereby you have the presentation layer, which will run a web server solution, and then the middle tier or the tier 2, which will be your backend system that must have the right binaries. So in this case, you have Python binary and Java binary, which are just things that needs to run for on the machine to make it run to be able to do Java and Python. And DB engine as well, which needs to run to be able to pass its data. Okay. And of course, because we are using the cloud, it's not too difficult to spin up a machine and then decide if you want to go the infrastructure as a service approach or platform as a service approach or software as a service approach. All that will be part of the decision that the team would need to make and say, are we going to spin up a vanilla machine and do the installations ourselves? Or do we make a hybrid where we'll spin this up, but we'll use this as pass, whereby we're not installing our database ourselves, but we're going to be leveraging the database out there. Maybe we would not install Apache system ourselves. Maybe we use existing one on the cloud. So we use it as a pass rather than as an IaaS, which is infrastructure service. That decision, it will be a collective decision of the team based on several factors, not least experience of the team, the time you have, the how much Amide is willing to pay to support the project, and so forth. So that would inform how you would implement the code. So a good chunk of this, you can implement them as IaaS or PaaS or even as SaaS as well. Because there will be some SaaS solution that will be almost good to go that you can just plug and play, and you won't have to worry about all this. You will just buy them on the internet and just use them and configure them, and you won't have to worry about setting up infrastructure. So it all depends if you want to go the IaaS, the platform as a service or software as a service, and several factors would come into play to determine which route you need to take. We discussed this, I think, last week or the week before. So this is what a tier system looks like. And so if we go back to the problem we want to see, so this is defined, talking about a two-tier system. What I've shown us is a three-tier system. I've deliberately reduced it to two so that we can forego this bit for now, so that we will not spread ourselves too thin. So we are only looking at the front end, the tier one, and the back end, which is the tier two. So that is what we are looking at for this project. So a front-end system running Nginx. So what we are saying here, for this website of things, you run Nginx. And for this backend system, you need to run Java and Python. So those are the two binaries that need to be present on the system. You don't need Java and Python here. And then you don't need Nginx here. On here, you need Nginx, and on here, you need Python and Java. And I say each tier should run two nodes in different AZ for redundancy. So what we are saying, each tier, instead of running one machine, we want you to run two machines. Okay, so let's just double that. Oh, blue green. This is blue green, and this one should run two as well. Green and blue. Okay. The reason why we are doing that is for redundancy. What do we mean? So say Ahmed goes live and he only has one system running the web layer or the Python Java layer. If that system dies or it gets overwhelmed for some reason, if it's just one machine, then you're going to have an outage because that system will not be available, and then the customers will not be able to use the platform. I don't know if you noticed last week, there was an outage on AWS because a data center had a problem, and that affected a lot of people. Part of the reason is because they don't have redundancy. So basically, what does that mean? So say somebody type www.tunde merchant.ahmedcoco.com. What typically happens is if you put down on the browser and you hit it, you would, what happens is the system will land you on the web tier, which will be this one. So you type it there, the first place you find yourself, this is you here or you here. The first place you find yourself is going to be on the web layer. That is where the traffic will go. That is what you see. You will then see a web page that will be the presentation layer. If that machine that should do that display is not available, then you're going to have an outage. The people will just see like, page cannot be displayed or something times out, whatever. The reason for that is typically all the machines we have. So let's look at this. Let me just move this around a little bit. So it's important we understand this. So what I'm trying to do here is this. Okay, I'm gonna take this one out just to simplify what we're looking at for a bit. Okay. So this guy comes in, is a customer. So when it's coming, so let's say this solution is hosted. So we have the web and Python all kind of sitting in maybe AWS, maybe Azure, whatever platform we choose. Let me make this purple. That's not a good color. Let's make it that. It's still not a good color. Yeah, let's do that. And let's send it to the back. Send backwards. Okay, send to the back. Okay, cool. Right. So this is an environment. We can call this a data center. This is literally a place somewhere where all these machines run. So let's say, for example, it's AWS data center. AWS data center. And then let's say you have chosen to use EU West. Just for illustration, let's say you use EU West 2. Okay, EU West 2 is the UK. EU West 2 is the UK. So you can use either be EU West 2A, that would be a data center in London, or you could be EU West 2B. The data center is literally a place, with an address. Like somewhere, so by EU West 1A it's somewhere in, I think around Oxford Street in central London, which is where they have their machines. So that's a physical location, and that's a data center. So if you go on AWS and you provision your machine, those machines are literally somewhere in London right now. If God forbid something happens to that data center, maybe there was power outage or something terrible happens and it goes offline, all the machines on there will die. They will not be accessible, and that will be an outage. Okay. But a smart person would say, okay, I don't want to put all my eggs in one basket. I would also create let's send to back. Okay. I will also create those machines in a data center B. And this is a B AWS EUS2 is in Slough, I believe. I might not be 100% correct, but they're not in the same location. There's one in London, I think there's one in Slough, I believe. So what that means is there's redundancy. You are not putting your eggs in one basket. You have one machine here that's doing presentation, and you have another machine. So your tier one is basically sort of spread across two data centers, and your tier two same as well. So let's say something happens to tier one, it doesn't matter because you're gonna have a load balancer here. So we're gonna have something like this here. Let's see. No, maybe that's not how to do it. So we're gonna have like let's do it like this. The customer comes there, customer goes up, and then traffic can either go here or traffic can go here. It might be we're sharing a 50-50, but they're gonna have so many customers. So they come in, they go through something that will balance the load. Let's call it the load balancer. and then we'll send traffic here, descend traffic here, and then traffic can then go to each of the data centers. Yeah, I'm oversimplifying it so that way we understand it. Yeah. So load balancer will send traffic across. So if there's a problem with EUSB zone, it doesn't matter. All the rest of the traffic will go here. So you will not have a downtime, even if there's a problem with one of the data centers. And that is what this is talking about. That each tier should run 2 nodes. So the first tier should run 1, 2 node. And the second tier should run 1, 2 node. Okay. Ensure you have a template to explore your VM creation. We're going to talk about this later. So we know what tier is, we know what infrastructure is, we know what front end is, we know what Nginx is, we know what backend is, we know Python, we know Java. Availability zone are your data centers. So availability zone 1, availability zone 2. Redundancy is make sure that if one fails, you're able to fail over to the other one. So you can have it as active passive, whereby you only running one, and this one is just remaining dormant. It doesn't take traffic. Uh, that's one way of looking at it. So this just does all the work. That's one way of doing it. And then there's a problem with this, traffic then start flowing to this. That would be active, passive situation. Some people run active situation. So traffic goes to both. So if there's a problem, it's just seamless. The other one just works. So what determines what you use will depend on the problem, the approach, the solution. But these are options that one has in terms of setting things up. So we are trying to shed light on these buzzwords before we then start looking at how to create these machines. Okay, if I wanted to do this, how do we get this done? So we've done a lot of engine exploration. We're gonna do it first the way we normally would do it, and then we're gonna put a bit of twist around it. Okay, so let's start with the front end system. And we can use a US1, we can use US2, it doesn't matter. We just make sure that the region, which would be your EU or your US, whatever. Choose the region you want to choose. I think we can make things consistent with, let's keep using Ireland. So, but we have to make sure we are using different data centers. So it has to be A, B. So Ireland has about 3 data centers, I believe. So you want to make sure you stagger your machines so that they're across different data centers. We are not going to include load balancers for now. We're just going to create the machines and just make them run almost independently for now. Okay, so what we are going to be creating is going to be 1, 2, 3, 4 machines. But we're just going to start with 1, 2 first. Look at it, understand it, and then we're going to kind of spread it further. The same concept I'm showing us is applicable on Azure, and when time comes for the next project, I will expect those people that are on Azure platform to continue to do Azure. I will continue to support you. So there's no reason why we can't be teaching 2 platforms at the same time. It's going to be extremely difficult. But every now and again, I will go on Azure, even sometimes go on Google Cloud to show us a few things. But predominantly, we will use AWS because they're still the leader generally. And that's why we are using them. But for people that are playing on Azure or using Azure, continue to use Azure for your project, continue to support you. But the concept is still the same, what we're explaining here. Okay, so we will start with the web tier and then we'll put some twist around it. So I want to start by creating which this switch we have done severally before, but there will be a few twists. Okay, so I'll go on my EC2, which will be your virtual machine on AWS. So you have to, okay, we want to create a machine. So we say launch instance. We've done it severally. Okay. So let's call it web server. Web server. So as I'm creating this, and I'm going to be showing us a few more things we probably have not been paying attention to up until now. Okay, so the web server will be the name, and we're going to create this, but we're going to come back, delete it, and make it better in the next iteration. So we'll give it that name. We're still going to choose Amazon Linux. Of course, you can choose any kind of Linux that you want, but just for simplicity, we take Amazon Linux, which is the operating system is going to run. The Amazon machine image is the configuration of what the operating system will look like. It's like you're buying like a Porsche, and what's the configuration that it comes with. Sometimes when you buy a car, they might, add some extra stuff to it and say, okay, they want to make it maybe auto driving. They want to make it as and maybe with an alloy roof. They want to make it have auto parking, maybe beautiful night vision, maybe metallic color. This is basically a special configuration of this operating system. So what are those extra things that this is the operating system, but what is the configuration would look like for that operating system? That's the AMI. So the pre-configured things that the operating system will come up with. Okay. And then the instant type is then how powerful is the car? What kind of engine? Is it a V6 cylinder? Is it a V8 cylinder? Is it a V14 cylinder? How many horsepower does it have? These are the kind of things that this is talking about here. So because you might have a well-tuned system, but not a powerful machine to exploit or explore that. So this instant type is talking about the physical power of the machine, whereas the operating system this is more about configuration and the type of the operating system. Okay, we're not going to change that. We're going to select a key, let's just take a key. And network security will come to this in a bit. Always make sure you have SSH. That allows you to get into the machine to authenticate to it. I'm going to click on advanced and show us a little bit of extra stuff that we might need later. So one thing I want us to pay attention to is what they call user data. We're going to come to this later. And we're going to see the importance of user data. So I'm going to create this machine. It's going to be our web server. Okay, I will launch it. Because it's going to be our web server, by the way, I think it makes sense to add HTTP to allow internet traffic so that we're able to hit it. And then we will just launch it because HTTP, we want to take it, we want to allow to take HTTP traffic. HTTP, let's not do HTTP, let's just do HTTP because we're not setting up any security, just simple HTTP for now, and we'll launch. Okay, this will do what it has to do, blah, 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 which we have done before. So we're going to log on to it. So this is the machine now. It's running already. This is the public DNS. If we put this public DNS, copy it, and we will expect that with HTTP, it should work, but it wouldn't because we don't have anything on it. So this is the plan. It should work. And what we are doing there is we come in here and hit here. Okay. So let's look at what we've done. So the machine we've created, we know what the image is. Where is the image? That's the image we used, which is the Amazon image. That's the key we used. We'll look at things around where is it? Networking. So one thing I want to show us here, which I missed earlier, is the location where the machine sits. So you can see this is in EU West 1 availability zone 2. So you can always choose where you want to sit. No, I think it's in availability zone 2, zone 1. Availability zone EU1, zone ID. Okay, EA. So it's sitting in EU West, EU West 1A. So there will be 1B and 1C. Okay, so this is the machine that's been created for us and it's in that location. So if you go here, that will be 1A. Okay, and that's where the machine is sitting. So it's a physical location somewhere. So for this machine, we want to configure it as a web server. So it's not running anything for now. So we need to turn an ordinary machine into a web server. So we would connect and then we'll put a web server on it. So this is just make it a blank web server. It doesn't have any of the Ahmed Coco stuff yet. So it's just going to be a bland web server. At least it should be able to respond when we do this. So for us to do, for that to happen, apologies. Please let me just get this chart quickly. Okay, cool. All right. So apologies for that. So what then happens is we will set up Nginx on this machine. So sudo yum install Nginx, and then -y just to quickly install it. And that should get Nginx installed. So I want to do this real quick. Okay, and then we can start the service sudo service Nginx starts, and then it begins to run, and this should now work. Okay, now this works. So we've turned that machine into a web server. But what did we have to do? We had to install that service on the machine. Okay. That is good, but it's not great. What did I do to turn this machine into a web server? So I did this installation. Okay, I could have removed it. So let's say I removed it. Sudo yum remove Nginx, I think. Okay, if I remove it, then it's gone. I've uninstalled it, and then this probably won't work again. Okay, because I've removed the binary, the Nginx binary on the machine. Okay. So what I could do, instead of always doing this all the time, I know to install it, I need to just run this command. Okay. I could script that easily. So what do I mean? So because I'm running Linux, I could easily script what I want to do and say, okay, this is on the machine, this is what I need to do to make my machine a web server. I just need to install Nginx. So I can write a little script. I can say vim, let me call it setup.sh, which is the script I want to write. So it's going to be a bash script. We'll run it as bash script. Don't worry about this for now. If you don't understand it, you would get this later. So I want to run it as a bash script. I'll say bin, this is what we call the shebang, bin bash. So all I'm doing is I'm just going to say I want to do, let's say sudo yum install Nginx. Actually, let me not use Nginx and -y. Okay, so that's all I'm doing. The only thing I've added is I'm just telling the system to run this as bash. That's what that shebang is for. So that's the script. I can then execute this script. So this is the script we have. I can execute the script. I'm going to achieve the same thing. I can just say sh -x to execute, and I can run that, and it will essentially do the same thing. In fact, I can also start it up. So this is not starting, it's executed, but it's not running. We need to do the start command. So I can put that in the script as well. So I can say, basically, I can say system enable Nginx so that when the system comes up, when it's, I can say something like service Nginx start, and then I can put sudo in front just to make sure for good measure. Nginx start. The reason I'm doing sudo is because I'm running as EC2 user. I am not an admin. I am not a super user on the system. If I change to root on the system, then I won't need sudo because I'm root. But because I'm not root, let me exit root. I'm back to EC2 user. That is why I need sudo to be able to do super installation operations and all those super admin operations. And that's why I'm putting sudo in the script. If this script was going to execute as root, then you won't need sudo. But let's just park that for now. Let's say we assume it's going to be sudo to install, sudo to start, and stuff. So we do that, and then let's run the script again. That's the script, we'll run it. Okay, now it's starting, and then boom, and it works. Okay, so what have we done? So we've moved away from manually doing stuff. We are now using script. We are putting sudo because this is, we are running this as EC2 user, not as root. And that's why we need sudo. Okay, what I could have done, instead of going through all this headache, is I could add an extra method. I'm going to show us what is extra. So extra command. I could do one extra command, which would be very useful later. Let me not add it yet. Let me not add it yet. I will explain this at some point. So, and why we need that, because if I add it now, you might not know why we need this. I'm going to keep it super simple. So we have the script now, right? And then the chronology of the way we do things is we will spin up a machine. We would manually do the YUM install and whatnot, but we kind of moved forward a little bit now. We're no longer, you don't want to be running YUM command, we want to be using script. So we are preparing a script that we can use so that when we provision the machine, we can then execute that script that will do all the hard work instead of us having to, one after the other, fire up the command. But we are putting the command together as a single script and we're executing as one. That's a step forward. We can take this a little bit further by looking at the way we're going to create our next machine. So if I wanted to create a new version of this machine, so this is what I'll do. So I will go back. I will say EC2. I will say launch instance. Okay, I won't care too much where it is launched for now. We're going to care about that later. So let's call it web server 2. We're going to still destroy this later. So we won't change much here. We're still going to go with masterclass 2025. We're still going to go with HTTP and so forth. If you want to have a look, you can take a peek into where it will drop it. So if you want to force the location where it should go, which data center it should go, you can specify here. Maybe you want to go to maybe data center B, A, B, C. These are the data centers. If you want to kind of force where it should go, you can force it. But we don't really care for now. We're going to care later. Sorry, the ability zone, sorry. So you can choose which one you want to choose, where it should go here. Okay, so I want it to be in A, I want it to be in B, I want it to be in C. So we won't worry too much about that for now. And what we are going to focus now on is we're going to select, I think we've selected the security, have we? HTTP 80. So let me just collapse this a little bit. The SSH is there. Okay, the HTTP is there. So those are the two that we need. SSH to connect HTTP for the web. So we go advanced, and then something we're gonna do here is we're gonna come here to user data, and then we're gonna put the script that it should run that would help us do what we think we have to do without us having to log in to do those things. For example, the Nginx creation, the all those little command that we execute, we can put them here so that the system can auto execute them for us while it's preparing the system. So what do I mean? So this script, I will just harvest it. So on the new machine, I would say just do all this. But I won't use sudo because it will run as root on the machine. So that's all. Yum install Nginx, service Nginx start. So if we've done it correctly, everything should just work as normal. So that's what we're gonna do. So we are preparing the script and we're adding as part of the system provisioning, so that this automatically get done for us without us having to lift a finger. So we launch. And then let's check the instance. Let's try it straight away. I've done it correctly, then it should work. Otherwise, I may have missed something. So let's go here. So let's put HTTP in front. HTTP. Okay, it doesn't look good for us. Okay, it works. You can see out of the box, it just works. The reason for that is because it's done all the heavy lifting, because we prepared it. So let me show you something real quick. This is the machine, right? Obviously, you can go to action. You go to instance setting, and then you go to edit user data, and then you see what we've done there. If you look at the one we created previously, which is this one, it doesn't have that in the user data because we manually had to set that up for it. So if you go, this is the one with provision previously. If you go to settings, you go to edit user data. Is this it? No. Okay, this is server 2. Let's check server 1. Okay. Server 1 should not have anything. So action, instance settings, edit user data. You see it doesn't have anything. But it does work because we had to manually set that up ourselves. So this is a good way of preparing your system. Whatever you need, you can pre-provision it here, and then it will be part of what you would, the system would do in setting things up for you. And it works, and it works nicely. Okay, so now I'm going to destroy those two. I'm going to destroy the first one. This is the first machine, and I'm going to create a third machine, but in a different way. So this is the instances. These are the instances. I will take this out. Just action, instance state rather, terminate, and it's gone. Okay, just roll that. Okay, it's gone. So this is the one we have now, 7.2. This would have probably gone now. Anyway, so this is gone now. This is the machine we are dealing with now. Yeah. So what I want to do now is, of course, I have the user data here. But sometimes what you want to do on the system might be so much more complicated that it might not be possible to write everything in a script. So obviously in this case now, we are super jolly that, we're able to package our thing in a script, makes us look professional. We do it, it looks good and whatnot. But sometimes in reality, things might be extremely complex, and you might not be able to sort of package it up in a script and add it as a user data. The user data is a phenomenal way of doing stuff. It's good, but it doesn't solve all the problems sometimes. Things might be a little bit more complicated. So sometimes it makes sense to create a system and manually do your installation on the system because the user data might be too complex to solve that problem. Obviously, in this case where we are dealing with Nginx, it's super easy. We will get away with using user data to pre-set things up on the machine. However, let's say we have a complex situation where the user data might not suffice. What we can do is we can spin up a machine and manually install what we have in it, but there's a but. So for example, in this case now, we have Nginx running on this machine. One thing I could do is when you set up a system, say you are dealing with a complex system where mere writing of code or user data might not suffice. So we have a system that's doing complex stuff, VM. In this case, you might not be able to use user data to solve the problem. Okay. So what you might need to do is you might need to manually log on to the machine. Okay. And on that machine, what you then do is you will do manual setup of whatever you need, manual setup. You will just get on the machine and install this, install that, install whatever you need. You install it manually. And when you're done, what you then do is you freeze this machine up. You freeze it up. And then you save it as a template. It becomes a template. So you freeze it up, becomes a template. So from this template now, if you want to create some machines in future, you can just spin them up. So you won't have to do anything. There will not be any manual representation because you will generate templates, VM1 of that, VM2 of the template. So you will not have to do any manual work going forward. You do the manual work once, you save it as a template, and from that template, you can then generate versions of the machines of that template. For example, in this case, one thing we can do is we have this machine here, we can template it. So what do? We will come here, action, imaging template. We'll create an image of this. We can call it web template. And then we would just create the image. So what typically happens is this, then the machine continues to run, but it's been snapshotted as a template. So if you go to AMI, Amazon Machine Images, you should see it there. You can see web templates, and then you can just call it like web templates again as a name. Okay. So now it's been prepared. It has to be ready. It's still pending. It's still kind of freezing, copying whatever you have in that instance, on that instance, and preparing it as a template. Okay, it's still pending. It will be ready at some point. So that will be this template. Okay, when this template, when the template is ready, you can delete the machine. You have the template frozen up and you can just work up that template. So that then gives us two methods of creating machines. One is using the user data and one is using templates. Okay. Just go back, images. Refresh. And it takes a while to finish, but as soon as it's done, we can begin to create machines of that template. And then, let's see, still pending. It takes a while. Okay, while that is sort of going on, um, so let's say I wanted to create a new machine. Of course, I know that is not ready yet. So if I wanted to create a new machine, I'll go to instances. So I can then say launch a new machine. I'm gonna call it web server, web server 3. Okay. So it's still gonna be an Amazon Linux, but the AMI will change. So I will say browse more AMIs. I will go here and I can choose my AMI. You can see, and then you will select that as the AMI that I should use. Okay, now that is going to use our AMI, not the one we prepared, and everything else remains the same. You choose the data center you want, you enable HTTP traffic, and then you would then fire up the machine, and then it should have everything that you need. So you fire that up. Okay, let me select the key I need and launch instance. Okay. But that then does what it needs to do, blah, 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 and everything is ready. Okay. So then the machine is ready and everything still stays exactly the same. So we've looked at two ways of spinning up a machine. So we've looked at using user data as now, also now we've looked at using templating and then using that template to create the machines that you need. So when you are playing with this, so when you are practicing, if you want to, it makes sense to delete the template when you're done. The reason for that is they might charge you for just keeping the template there. So you have to delete all the instances that are based off that template before you can successfully delete the template. So just remember that. Okay. Okay. Before we go any further, so these are ways of creating the machine on here. Okay. You can see I'm using the console to click and get things done and what have you. And currently we have 3 machines here. Okay. In reality, I still haven't lost sight of the fact that we haven't done this Java. So I don't want to finish it. I just want to kind of give us a background and then hopefully we can finish this up as a this week task. Uh, um, so I would deliberately not finish this up, but I'm going to kind of provide us all the ingredients that we're going to need to hopefully finish it ourselves. So we've looked at creating machines using, obviously using script, using user data, and using templates. Another way of creating machines would be to use the command line. What I mean by command line. Currently now we are using the console, sort of jolling away, clicking and, having things sort of drag, drop, click, which is good. But in reality, sometimes you want machines to create machines. You don't want people clicking to create machines. The reason for that is people do make mistakes and sometimes you might need to provision 10, 15, 20, 30, 40, 50 machines. And if you're having to go and manually create it, it will just be, slow and prone to errors. So usually people will write scripts to create machines, not just for the fun of it, just to have something repetitive, something consistent and something reliable in creating, in managing your infrastructure. So that's what they call infrastructure as code. So the infrastructure we've been creating now, we're not using code. We're just literally clicking to create our VMs and stuff. Well, you can actually do all the things we are doing here just by using code and code alone. So, but before we get to infrastructure as code, I want us to look at what this interface looks like on the command line. If we wanted to use the command line to explore what we have on here and even do some of the tasks we see here. What do I mean? So AWS, Azure, Google Cloud, they all have what they call the CLI, command line interface, which allows you to explore what they have on the console, but on the command line. And they have several reasons for that, not least, simplifying your work, allowing you to do automation and all the rest of it. So I want to kind of let us see what this will look like if you wanted to exploit on the command line. And then I would kind of show us why it would make sense to explore the command line a little bit. So this is what we have on the console. Right. If I wanted to export this on the command line, I need to install what they call the AWS CLI on my machine. So AWS CLI, it's just a command line interface, which you just download and install. Linux, Mac, or Windows, there's installation steps there you can use. Okay. And for people on Azure, there's Azure CLI as well. Then you just basically install Azure CLI. Okay. And then with Azure CLI, how do you install it? Create Azure resources, Windows install, Linux install, and all the rest of it. So when you install the CLI, okay, depending if you're on Windows or Windows or Mac, you will go to the terminal. If you're on Windows, you open your Git bash after installation. So do the installation. Obviously, AWS what we are giving preference to. So the AWS installation after installing on Linux or Windows, whatever. After doing that, go on your terminal. So in your case, Git bash on Windows. If you're on Linux, if you're on Mac, you go to terminal. I see. And then if you have successfully installed it, if you type AWS, you should get something back. That will tell you if it's successfully installed. You should get something back. And that tells you if it's installed. I don't think, does it take version? Let's see. Okay, it does take version. So it can tell you what version that you have installed, blah, blah, blah. So you can use that. So if you are successful with that, then obviously you've done the installation successfully. So I'll leave that to you to kind of work out. AWS version, that should help you to, after doing the installation, that should work. And just go git bash and then open your git bash, type AWS version. You should see that. If it's not prompt, your version might be different from mine. At least it should come back as something not showing errors or say command off or anything or something like that. So with the CLI, that gives you the tool to explore the AWS platform or the Azure platform, whatever the case might be. Okay. So with the CLI, we want to be able to, specifically for these machines now, we want to be able to manage machines, create machines, uh, um, delete machines, explore machines. In this case, we're only focusing on machines. There are a lot of things we can do, not specific, not only to limited to machines, but across the board on the AWS platform. If you have the CLI, for example, the CLI amongst many things, if you say CLI AWS help, I believe, it will tell you all the right? These are all the things you can manage. So a whole shebang of them. These are services that on AWS, it just goes on and on and on and on and on and on. In our case, we are only focusing on one, which is this EC2. And you can then see how many services we are talking about. Just too many, too many. That's why I say on these platforms, you have to choose your battles. There are just too many things on there. But with the CLIs, you can potentially manage, or use any service that you want via the command line. Okay, so that's the first thing you should check. Check the version. The help shows you what is possible. But more than anything, you need a way to connect your AWS CLI to your AWS account. So you have to have a way to authenticate on the AWS platform from the CLI. Okay, I think the CLI is too far. Let me bring it next to it. So we've got the platform here, and then we got the CLI here. So we need a way to essentially, we've got the CLI, but we need a way to connect the CLI to work with the AWS platform. Okay, so currently now that is not possible. So the first thing we need to do is we need to set up the permissions, the roles, and the users that will make this possible for us. So essentially on these platforms, usually when you have on any cloud platform, there are many ways to connect. Okay. One way is you just turn that, just turn it. If I can only turn it. Okay. Okay. CBV. Okay. Okay. So this is your cloud platform. Cloud platform. Okay. How do we connect it? So one way is the console, which is the web. Okay, I think it's upside down. Console. Okay, it's properly upside down. So let me just use text. So this is console. Console, which is the web, which is what we are using. So this is how you will connect to your cloud platform, such as AWS, as a user of the platform. So we would connect as using the console, which is what we are doing here. We're using the console to create machines, delete machines, and what have you. That's one way. Another way would be to use API libraries. API libraries, which is basically writing code like Python and what have you to automate how we connect to AWS platform or any cloud platform. Another way would be to use the CLIs. CLIs. So which is the command line interface, which is what we are exploring now. Okay. And then you can also use third-party approach. Let's just summarize it as that. Third-party approach would be another way to connect to them. So this just is applicable to any of the cloud platforms. Okay. The only thing though is when you are connecting to them, to the platform, when you're connecting to the platform, there is an intermediate level here where authentication and authorization of authorization are managed. Can you log on? Authentication. When you log on, what permissions do you have? Authorization. The fact you can enter a house does not mean you can go to their kitchen and cook. Yes, you're allowed. You're only allowed as a guest. Yes, you're allowed. But you're only allowed as a cleaner. You authenticate, you come in, but what can you do? That is what authorization answers. So the concept of authentication is there, and the concept of authorization is there. So are two different things, and those have to be managed and managed correctly. So you might have different users connecting via the console API library. The way they connect will determine how they authenticate and what authorization they have on the platform. Okay, you're connecting via the console because I set up my account as root and I log in and all the rest of it. If I want to use the CLI in this case, the way I'm going to authenticate is a little bit different. So there's a concept of user group and concept of users and concept of permissions and how those are managed. For me to be able to set up the CLI correctly, again, we're using CLI because we want to simplify. We would engage the AWS platform so that we don't have to come to the console all the time. We want to be able to use the CLI. So to do that, I have to use a service on AWS called IAM, Identity and Access Management, on the platform to set up the necessary groups, necessary users, and the permissions I'm going to need. Without that, I can't use the CLI. Okay, so I have to go here and I will type Identity and Access Management. Okay, I'm going to go there and I'm going to set things up. Just for simplicity, I will set up user groups first. So you can just copy what I do because when you are kind of early in the game, things can get quickly murky here. So it's important to kind of play it in the simple way first. And when you become like proficient, you can then begin to, you know, explore things and do more funky things. But for now, just keep it super simple. So what we want to do now, the first thing is the reason why we are here is because we are trying to set up the necessary groups, necessary permissions, and necessary users that we're going to need for our for that CLI, which is the one we installed here. It won't work without having those things set up. So, right. So they're here. So the first thing we do is we set up a user group. Okay, we're going to create a user group. We can call it, let's call it DevOps. DevOps. Let's just keep it super simple. Let's call it DevOps. And then that's the name of the group. What permission do you want to give the group? Let's give him admin access just for now. That's like a top access that you can have. Let's just leave it at that for now. And then we'll create the group. And the group is created. So the next thing we're going to do is we're going to create a user. Then we're going to create that user. We're going to call it DevOps, DevOps user one, something like that. We won't check this. Let's just keep it super simple. Next. And then we add him to the DevOps group. And then next. And then we'll create the user. So the DevOps user one is created now. And it belongs to the DevOps group. And the permission is inherited from the DevOps group. Okay. And that's the permission it has. That's the group it belongs to. So when this user is set up, a few things happen. Obviously, the permission is set up, the group is set up. There's something called security credentials that is set up for the person. So multi-factor authentication is there, access key is there, API key, SSH key, the list goes on. So these are the things that a user would have access to in terms of what you can do potentially and the artifact is going to need to be able to do that. Specifically for the CLI, which is this one, we are going to need what they call the access keys. Okay, so you can see the access keys needed for AWS CLI, blah, 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 blah. So you're going to need that. So you just say create access keys. And then let's just say we need it for the command line interface. Just keep it as simple as that. And then you understand. And then you would do next. And then let's say create key. It's important to download the key. You can show. And then you can download a CSV file. I will go into my downloads, but you can also take note of what the access key is and what the secret access key is. With these two keys now, you can begin to interact with the system from your command line. With these two keys, you can begin to use the command line to interact with your AWS. For example, from my command line now, I can explore my running instances. I have two running instances here. So how do I do that? I have the keys now. I've downloaded it, but I still have them here as well, just for good measure. So if I go on the command line, I could do something like, the first thing I'm going to have to do is I have to fetch the keys and ensure that I do the right export of the keys. I need to tell the command line here the keys to use when it needs, before it begins to interact with AWS. Okay, what do I mean? So AWS is the command that we need to use. So we know we have AWS. When we did AWS help, we know we have a lot of options, and we want to sort of start exploring the EC2 to get what we need from the machines, create machines, and all the rest of it, right? But before we start doing that, we need to do an export of this key. We need to make this key accessible here or available here. So we'll copy the keys and we'll export them on here. So I will do export, and I will do the access key first and the secret access key next. So I will do export AWS access. I would say access key ID equals, and then AWS access key ID. I will then copy this key, and I will put it here. I will do export AWS secret access key, secret access key. You say is this one. Then I will do export of the region. What's my default region? What region do I want to land? Okay, this is where I want to find myself. So EU West 1. So I will also do an export of AWS default region. Default region. And then I will say it should be EU West 1. Okay, I got that wrong. That should be it. Okay, so I've done the 3 exports. So with this now, this command line has the secret keys now. Of course, I've downloaded it in my download. So if I lose this page, it's not a problem because the file is in my download. So but I've got the keys. So I've done the export here. With that now, I can then check to make sure that this user can begin to explore the system. How do I know that all these exports is successful? I would do what we call get caller identity. I would say AWS STS get Caller, identity, TITY. Okay, now I say, okay, right. There's a DevOps user one. I know about him now. It's good. You can begin to explore. So it's saying I know this guy now, and that will be based on this thing I supplied. So now it knows about the user, and the user can then begin to explore the system. There are other ways called AWS configure, which I don't want to show us now, because when we start doing proper automation, it makes sense to use the export options. You see, it has its pros and cons, but we will come to that later. So if you just do the export, access key, CLI access key, and region where you want to find yourself, that should be enough to begin to explore the system in terms of getting what you need. For example, I could do something like AWS EC2. I can say describe instances, and it should be able to go on the system and tell me about the instances on the system. So for example, it's found one with this IP address, 82, 86, 132. If we go on the machine, on the system here, and let's see, let's refresh this. There's one that is 82, 86, 132. You can see that. And the other one is 101. So 82, 132, that's one machine. And then the 101 probably is somewhere, and that's the one. Okay, it's just a lot of systems. So let's see, this one is 101. That's the 101 one. You can see those are the two systems. Okay, it's giving us a lot of information, probably too much information than we like. So the way this information is structured, if you see, is a long list. Is everything starts from reservations. That's a top level. Then there's a square bracket, which is almost like a list of what is possible in reservations. You then have a list of reservations. In that list, you have groups, you have instances. Groups tend to be empty. So in reservations, you have a list. One is in that list, you can have group one, list one. In list one, you have group instances. And then inside instances, you then have sub group or sub list. And that will be something like ID, name, and what have you. What does this mean? That means that I could target to only generate things in reservations, instances, and maybe just get just say for example, just for good measure, we want to get just the public DNS name. So we'll go reservation, we'll go instance, you will then go public DNS name, something like that. What do I mean? So I would change this query a little bit, but this information is too much. I would then say I want to change the query to reservations. And I might go copy it, reservations. Everything in under reservations. So you might have it as a list, or in there, I want to do dot instances. So if you look at reservation, so if we go reservation instances, maybe under instances, there's another square bracket. You can do instances star and then target public DNS name. So instances capital S. So let's try that. So reservation instances. And then we do square bracket as well. Star. And then probably we would then do let's do that public DNS name. I think that should be it. The only thing I think I missed is there should be a dot here, I suppose, and that should do it. Okay, not really, because I'm missing the end quote. Voila, you can see that. So that's a way to kind of just sift things out. And then you can change this from being a JSON, which is the output type. Output currently, output is JSON, which is what we have, which is this structure. And that is why we have it as funny square bracket. But we can change outputs to text, I believe. You can see that. We can even change output to a table. You see that? And then the only thing, these are not the only things we can get. We can go back and look at it and say, pa 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 pa. We can also include, so we're currently looking at DNS name. We can also potentially add IP address to it and then say copy, and then we can say that comma, because it's that same level, comma IP address. And then it should give us two things. You can see that. And then list goes on and on and on. So that's how we can basically explore it. We can not only do that, we can actually create machines here as well. Okay, that's so we can do something like basically create our own machines. We can do something like EC2, AWS EC2. If you don't know how to do EC2, we can just do help EC2, I believe. Or EC2 help, something like that. Something EC2 help. Yeah, EC2 help would then tell you what you can do with EC2. A lot of things. All this command and the describe, the EC2 describe, you can see it is to describe. Okay. Describe instances, the one I was playing with. If you need more info on that, you can even get more info as well. It goes on and on and on, and then you can quit. If you don't know how to use it, you can just say, I think help describe instances, I believe. Yeah. Okay, no. So I think describe, it's to describe instances. I think, let's see. No? Yeah. So this would then tell you how to use the describe instances. Things I was playing with. You will see examples. You can see it will describe instances, instance ID. You can specify the instance ID if you just want to do one instance describe. You know, it will tell you how to do your filtering, filter. It will tell you what kind of output. You see all this output tag, filter table. So this is how you will exploit by just saying, help me, whatever command that you need. Okay, please don't forget that because there's only so much we can cover, but you have to, even in reality, you won't know how to use it because you can't put it in your head. So you will always know how to look for help to do what you want to do. So this is very handy. How do you get help? That is very important. So let's say we wanted to create a machine. It's same thing. We say run instances. We'll say blah, 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 blah. Just get this. So to run instances. Run instances. If you don't know how to do it, just say help, and then it will give you how to do it. And then it will even give you examples. You can see it's a long list, and you can just explore. This is an example. Run instances, image, instance, how many subnets, name of the key, security groups, tag, blah, blah. It's not. you are covered. So it's just a case of looking for example and then creating it. So, but let's create one real quick. So AWS EC2 run instances, type, and I will say image ID. So let's go get an image. So because we're gonna need an ID for the image, just bear with me. So we can use generic image or we can use the image that we created. So AMI, let's get our image. This is the image we created. That's the ID of the image. The image ID is that one. So we can copy that. Image ID is that. We can do instance type. What kind of instance do we want? Instance type. We might say we need a T3 micro. Okay. And then the key we want to use, key name. How do you authenticate? We've been using the, I think we've been using the master key, something like that. Let me see. What key have we been using? Let's see. Key. We're using the master key. I want to get the exact name so we don't miss it. Key name, master key. So in your case, you can always go and look at your key. So key name. Okay, so this is the master key I've been using. Okay, then that will be your key name. And then key name, master key. Okay, and then I'm not going to specify anything. The only thing I will specify is security group, and I'm going to let me not even let me specify that. So you've got the image ID, you've got the instance type, you got the key name, and so forth. Okay. One thing that you probably would need, which is, I can't explain now, but I will explain maybe next week, is you have to have a security group ID, which is called security group IDs, group IDs. So this is just this is almost the same way when you're creating an instance, you need to basically specify a security group. Let's say we're doing it from here. You recall that you would, give it a name, some no, blah, 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 and you come here and you specify this is the security groups. And that is what we're trying to specify here. The only problem here is to simplify it. You have to use an existing security group. So make sure you have if you come here, security groups, a lot of security groups have been created when we're playing with the machines. So you can take any of the wizards. Don't take the default. Just look at one of the security groups, copy the ID. I can literally choose anyone that allows HTTP access. What do I mean? So today we've created a lot of security groups. I think it goes by number. This is the last one that we created with the last machine that we used. Why is this important? When you check, it has access to 80 and 22. Without this access, you will not be able to, when something's created on the machine, you will not be able to access the web content or you will not be able to SSH to it. So for now, make sure you're using an existing security group and check that it has 80 and 22. So the security group we're going to use should be an existing one. Don't use default, just take one. If you don't have one, you can create one yourself. But make sure it has access to SSH and HTTP. And then you will get the security group ID, which is this one. And then use it here for now. You're going to see how to make this better later. Just paste that there. And I think these are I'm really glossing over so many things for now, just to simplify. And I think this is what we need. Okay, I think we've succeeded. So it's creating the machine. So if we go on the console, we should see some machine being created, I suppose. Yeah, you can see that it's being created. We've missed out, name tag. That's not a problem. We can We can, next time we're doing that, we can just specify the name tag there, just a tag certification. We can give it a name, but that's not a problem. Just for now, let's just simplify and just say from CLI. Just one step at a time. Okay. Okay, now this machine is being created. Remember, we are using the AMI that we created from that already kind of templated. That's the one we leverage. You don't have to use that. You can find any AMI you want and just use it. But the key thing is you need to find the image ID. So if I didn't want to use that AMI, there are a lot of AMIs that I could use. So if you say, for example, instances, let's say you launch. These are our AMIs. Of course, you can take a list, but you need to get the AMI ID. This is what is important. Get the ID. But in our case, we are using our own AMI, which is my AMI, and that is the ID, and that is what we use the command line. So the machine is created. We go here. Dashboard. Instances from CLI, and is it done? Okay, I think it's still saying it's coding. Let's see if everything works as expected. Let's copy that. Okay, HTTP. Okay, okay, here's the inquiry. Is it HTTP? Let's see. HTTP. EC2. Okay, let's log on the machine. Let's see if we can get to the machine. Okay, the machine is on here. Maybe it's not done yet. Maybe it's done. We'll figure it out. So, all right, from CLI, it's still initializing, it says. Okay, let's see if we can even connect to it. Saying as root, let's connect at EC2 user. Let's see that. Maybe that would work. Let's see. Connection is taking too long. Okay, we're in. Okay, let's see if this works now. Maybe it was just taking time to provision. Okay, it doesn't work, I suspect. Let's check. Let's check. Let's say sudo service. Maybe Nginx is not running. Nginx start. Maybe. Okay, maybe it wasn't running. Now let's run it. Okay, now it's running. So what's happened is we created the machine. Nginx is already installed on it, but it didn't start. Okay, and I know the reason for that. The reason for that is when we were creating our initial machine, if you remember, this was the template we used in creating the machine, which was the user service. There should be an extra command here that will tell the machine to always start Nginx when it runs. So it's called service enable Nginx. I will share that on the platform so you can include that. I didn't want to include it so that if it failed, you would know why I'm adding the command. Otherwise, if I added things to just work and you won't know what we've done. So for you to always have this running automatically, there's an extra command that needs to be added to that template of the image. Where is it? To just ensure that Nginx will always auto start. Okay. So where does this leave us? So where this leaves us is this. Today, what have we done? We've created a script and we've created a few commands that allows us to create an Nginx instance. Okay. So what we should do, we have to be very careful, is we are going to do an export of we're going to copy the command that we've used, so we keep it somewhere so we don't lose it, as well as the command we've used to create our instance. And I'm going to give us a little bit of a warning first to make sure that we're not doing things wrong. So what do I mean? So whatever we've done today, we want to make sure we capture it and keep it in a version control system. So we've created a script today. If we don't have that script, when I delete these machines, all the script goes away. All the scripts will go away. So I want to capture that and put it in a version control system. Okay, so what do I need to do? I will do something like this. I'll go to my maybe temp of my system. This is my local system. I probably will create a directory. I'm going to call it like directory. I will call it, let me call it class 6. I'm going to go into class 6. Okay. And I will go to I'm going to go to my GitHub. I will do GitHub template. Okay. I'm going to create a new repo. And I'm going to call new repo. We call it cloud. Let's call it with cloud intro. AWS CLI, something like that. I'll create that. And I'm going to download that. I'm going to copy that. And I will come here, I will do git clone. And I'm going to do that clone here. And I'm going to set it to cloud intro. Okay. Now the next thing I'm going to do is I'm going to launch my Visual Studio Code so that I can basically I'm just going to say code open. Okay, that's strange. Please bear with me. Let's do that. Let's do it again. Code open. Okay, yeah, it's launched. Let's put it, yeah. Let's put yeah. Okay, and then let's close all the shenanigans. Okay, all these ones. So we go here. There's nothing in there. So we create our first file. We called it the setup. Remember the setup.sh command file. And in that setup, because we want to preserve all the things that we've done. So this goes there. If we can copy it. Then we'll put that there. There was something else I wanted us to add, which is, I think is the enable service. I remember it. I think it's just service. I'm gonna double check this. Service enable Nginx, something like that. This is just to make sure that Nginx will always start when you do it. I will double check that. Yes, I think it's correct. I'm gonna double check it later, but yeah. So this just makes sure that we won't have to jump in to start it next time. It just automatically start. Yeah, and I'm gonna set that. The other thing I want to do is maybe create another file and I call it AWS CLI. AWS CLI run instance. And I'm just gonna create this as just harvest this one. And I'm gonna put it here. The only thing I would do is, because this is gonna be on the internet, I would change this to XXX, just to make sure you're not exposing yourself too much. Key name is YYY, and group maybe is ZZZ. So just to make sure you're security conscious, and do not put your keys here. Don't do all these export keys. Your keys should not come here. All the keys that we created, all those export things that we did, export, none of those things should be on here. Okay, I only created two files, that and that. And what I'm gonna do is I will then go here. I will say, I will commit, I will say class 6 artifact, artifact. I'm gonna commit and push. Okay, and that should have pushed things here. If I refresh that. Okay, I've got my files here now. So this is to help anyone who wants to do the setup, the cd command. So if you want to kind of, do the same, obviously you don't have a file or the files where all these things are stored. So I would expect you to, in terms of what we're going to do this week, we are going to use the command line to create these machines. 1, 2, 3, 4. We've played with one, but we're going to create one in EUA, one in EUB, this in EUA, this in EUB. The command you are going to use to create them, I want you to upload it in your repo. It doesn't mean it will run from your repo, but you can upload it in your repo. Okay, and you can either template your work. If you want to capture the image, where is it? If you want to manually install one as like the template, and then capture it as a template, and then create your two machines of that template, that's fine. That will be something you specify in your image ID. It's an image that you generate. You can do it that way. Another way to do it would be to not use a template. You can use this command and use just a normal image, which what I mean by normal image, not a generated image one, just out of the box image, such as this one, which is out of the box. So this one is out of the box. It's not your private image. You can go ahead and get your own private, but this is out of the box. If you use out of the box image, it means you have to manually install what you have on the machine. Of course, you can do that using user data. If you want to use the data on the command line, you can write your code in GitHub, put it there, and then you can reference that code on your command line. What do I mean? So currently now, if I wanted to create a machine and I wanted to use specify a script that I'm going to use for the generation. So the thing we'll be using with user data, you can use it here as well. So it's just going to be the same thing, of course. And then the only extra thing that you then specify -- user data, and then you specify the file, and the file has to be local on the machine here. File, in this case, maybe you then have it as setup.sh file. And that file has to be here. For example, so currently now our file is here, so we can just do create instance, run instance, okay. And then we say plus dash user data. Then we say file, and then we say setup.sh, which is the setup file that we use, and then it will set it up. But that means if we are doing this with this, it doesn't make sense because the code is already in this image. That is the derived image. But if you're using a out-of-the-box image that doesn't have anything, you might need to use user data to do your installation. You just set it up that way. Of course, I'm going to be available if you need more info. But this project will stretch you a little bit. So if you start early, that will be good. But we're trying to bring all the things we've learned together and put it together this week and do something a little bit more advanced. I know I've taken a lot of time. All right, cool. Thank you very much. Any questions or comments? No, this week, this one has been interesting and a bit stretched. Any questions or comments?
Yeah, thank you very much for the training and the explanation, very elaborate and very clear. I just want to ask, from all the things we looked at today, are there any possible likely interview questions that could come up around things like this that we could just take to heart?
Great question. Thanks, Nate. Yeah, there are a few. Obviously, one of the important question is what is version control system and why would you need one? Okay, that's a very valid question that can be asked. What's a version control system? Why would you need one? And then the other one might be in terms of the tier structure we talked about. What do you understand by a 3-tier system? And describe one. Okay, we talked about tier 1, tier 2, tier 3 system. What are they and why would you need them? And that question is, what is redundancy and how do you implement it in a cloud system? So we talked about, having things in different availability zones, which are data centers, and then you can have them as active, or active passive, so that if the active has a problem, the parties become active and vice versa. Honestly, there are a lot of questions that can be asked there, but what we can do is, which we will do actually, is when we do our first major project. So every month we're going to have a major project. We are going to do like a project defense, which is almost like an interview where all these questions will be asked because we are trying a lot of things out now. So it's not looking like, entry level childish again. So I think the way we're going to do this that would work would be when we start doing our major projects, as we always done, we will have people present their work and then we're going to quiz them as though it was an interview. Does that cover it?
Thank you very much. I appreciate it.
All right, you're welcome. Any other question? Anyone? Brilliant. Thank you, everyone. Have a blessed week. Please, I would encourage us to start this project early enough so we can finish, but this will stretch us a little bit. God bless. Have a beautiful week. Thank you.